Hi, I'm ATH. Welcome to this lesson in my chemistry series on ore extraction. First, let's head up our notepaper like this with your name, the title and today's date. Pause if you need to get yourself organised. Metals are incredibly useful and used in a whole range of settings. They are essential for our modern technological world. Iron, for example, is used for making cars, ships and bridges. Copper is used for electrical wiring and water pipes. Aluminium is often used to make aircraft and drinks cans. So where do we get these metals from? In simple terms, we dig them out of the Earth's crust. But in a little more detail, we can split the answer into three, roughly following our three metal categories of precious metals, everyday metals, and reactive metals. Precious metals such as gold are unreactive and do not form compounds with the chemicals around them, so they can be found as pure metals in the ground. You can literally dig them up and use them. This is why they have been known by man and used for tens of thousands of years. Everyday metals such as iron and copper are also found in the ground, but as these metals do react with the chemicals around them, they're found in the form of metal compounds. Iron, for example, is found as iron oxide in red rock, which is known as the ore hematite. Copper is also found in the ground, but as copper carbonate in a green rock called malachite. These compounds are found in rocks which we call ores. We extract these everyday metals from their ores using chemical reactions, which we will look at in a little more detail at the end of this lesson. In order to extract metals from their ores, you need some scientific knowledge and the ability to produce a large amount of heat. So these metals have only been able to be extracted for a few thousand years. The Bronze Age, around 3,000 to 5,000 years ago, was the era when the extraction of copper had been discovered, and mixed with a little tin it made bronze, which was used for tools and weapons. The extraction of iron was not discovered until much later, as this requires a much higher temperature. The Iron Age, around 2,500 to 3,000 years ago, saw iron and steel replacing the use of bronze. Reactive metals such as sodium and potassium are very reactive and also found as compounds in the Earth's crust. They're very difficult to remove from their ores chemically as they are so reactive. So we extract reactive metals from their compounds using electricity by a process known as electrolysis. Here we have some molten sodium chloride, and if we pass an electrical current through it, the chlorine and the sodium separate and the sodium collects on the electrode attached to the negative end of the battery. So let's make some notes on these three types of extraction. And now for today's joke. Steel makers are worried about the high price of iron. They say it's a terrible ordeal. I know, that was an awful joke. Anyway, let's have a go at a few questions. So how did you get on? Question 1. Give two uses for each of the metals iron, copper and aluminium. So you could have had any two. I've put here iron, cars and bridges, copper, wires and pipes, and aluminium, planes and cans. You kind of deviated for that as long as they were right. So 6 marks, 1 for each there. Question 2. Why did ancient humans first discover metals such as gold thousands of years before discovering more useful metals like iron? So gold can be found as a pure metal, whereas iron is found as a compound and has to be extracted from its ore. So I gave 3 marks there, one for saying that gold's you can find pure, 1 mark for saying that iron's found as a compound, and the last mark for saying that you need to extract it. Question 3. What is meant by the term ore? Well, an ore is a rock that contains metal compounds, so 2 marks if it was specific. Question 4. What's the name of copper ore and iron ore? So copper ore is malachite and iron ore is hematite. Question 5. Give the chemical names of the copper compound and iron compound found in their ores. So copper is copper carbonate and iron is iron oxide, so 1 mark for each of those. Question 6. What is the difference between the method used to extract copper and sodium from their ores? So copper, we can use chemical reactions, which we'll find out in a few moments, and sodium, we use electricity. 1 mark again for each of those. So a total there of 17 marks. There are 2 ore extractions that you need to know. So let's have a look at our first one. The extraction of copper from its ore malachite, containing the green compound copper carbonate. So this is a piece of malachite copper ore, and you can see that green powder that's contained inside the rock. So that green powder is copper carbonate, which I've got in this test tube. In my other test tube, which we're going to be using for a test in a minute, is lime water. That's calcium hydroxide solution, lime water. So I've taken my 2 test tubes of copper carbonate and lime water and I've set them up like this. I've got a bung in the top and a delivery tube going between the 2 tubes. So I'm heating up the copper carbonate on the right, and you can see a few little bubbles now coming out of the delivery tube. As we heat, if you have a look at the copper carbonate, it's going from a green colour to a black colour. And you can see some gas coming off and moving the surface of the powder as well. So what's happening is a thermal decomposition reaction. The copper carbonate is breaking down into 2 products. The black copper oxide and the gas that's being given off is carbon dioxide. And you can see the lime water there going cloudy or milky to prove that it is carbon dioxide. So we've got copper carbonate decomposing using heat into copper oxide and carbon dioxide. Little safety tip here: when we stop heating, we remove the delivery tube. Otherwise, the water can be sucked back up the delivery tube, hit the hot glass, and it can crack it. That's called suck back. So here we've got our copper oxide, and we're now pouring that into a crucible. And I'm mixing that now with some carbon. So we've got copper oxide from the thermal decomposition, and I'm mixing that with carbon. And the carbon and the copper are going to undergo a competition reaction for the oxygen. So I've got copper oxide competing with carbon for the oxygen. So that's taking place in this crucible, which we use for heating things in a high temperature, and we sit that in this. This is called a clay pipe triangle. So we're going to set that up on top of a tripod. So we've got our crucible, clay pipe triangle, and our tripod, and then underneath we're going to use a Bunsen on the hottest flame, the 500-degree roaring flame. This is what we can see from the top, and we can see how it's all set up there. Very quickly it starts to get incredibly hot, getting it up to about 500 degrees, and we can see the bottom of the crucible glowing orange there. Inside the crucible, the competition reaction's going on, and you can now see that the surface is now moving about as the gas is escaping. So carbon is taking the oxygen away from the copper and producing carbon dioxide and floating up. That's leaving behind, hopefully, some copper. And if you have a look closely inside the crucible, you can see the reaction going on. You might even see the odd little spark there. So when that reaction has completed, we can then carefully remove the crucible and then pour the contents out here onto a heat-proof mat. And now what we're going to do is see if we can find any copper. If this was done at 1,000 degrees, then the copper would be quite evident. It would pour to the bottom as molten copper, but this is only done at 500. So if we scrape around, we find a few little flecks there of copper, that reddish brown metal sitting there in the middle. So we've managed to extract some copper from copper carbonate. So that was a two-stage reaction. Firstly, a thermal decomposition reaction where the heat breaks down the large copper carbonate compound into copper oxide and carbon dioxide, which floats away as a gas. We then have a competition reaction between carbon and copper for the oxygen. Carbon is higher in the reactivity series than copper, so manages to remove the oxygen from the copper oxide, leaving copper as a pure metal. Again, the carbon forms carbon dioxide, which floats away. So the two-word equations are copper carbonate goes to, with heat, copper oxide plus carbon dioxide, and that's a thermal decomposition reaction. And the number 2, copper oxide plus carbon goes to, with heat, copper plus carbon dioxide. This is a competition reaction. If we do this in a very hot furnace, we can get pure molten copper forming at the bottom. Copper melts at just over 1,000 degrees Celsius. This process of extracting metal from its ore using heat and a competition reaction is known as smelting. Let's make some notes on the extraction of copper from copper ore. Smelting with carbon is also used to extract iron from its ore, hematite. Iron is found in the ore as iron oxide. So a simple competition reaction can be used to extract the iron. The word equation is iron oxide plus carbon goes to, with heat, iron plus carbon dioxide. If the reaction is carried out at a very high temperature, then molten iron collects at the bottom of the furnace. The melting point of iron is just above 1,500 degrees Celsius. During the Industrial Revolution, a huge amount of iron was required, and this was obtained due to an invention called a blast furnace, where hot air is blasted into the furnace, making the smelting more efficient. So let's add some notes on this reaction. Now let's have a look at a few questions about those two extraction methods. So let's mark those. So question 1, what is meant by a thermal decomposition reaction? So that's where a large compound is broken down into smaller compounds using heat. So 2 marks for that. Question 2. What is meant by a competition reaction? So that's a reaction between two metals for the possession of oxygen. So we normally have one metal and one metal oxide. Question 3. What gas is produced during the extraction of both iron and copper from their ores? That's carbon dioxide. And if you remember from the video, the test for carbon dioxide is that we bubble it through lime water and the lime water turns cloudy or milky. Question 4. Which ore extraction occurs at the highest temperature, copper or iron? If you remember, copper melts at just over 1,000 degrees Celsius, whereas iron is just over 1,500, so iron. Question 5. What are the products of the thermal decomposition reaction of copper carbonate? So copper carbonate breaks down into copper oxide and carbon dioxide. So 2 marks, 1 for each there. Question 6. Which is more reactive, iron or carbon? Well, we use carbon to take the oxygen away from iron oxide. So carbon is more reactive because it ends up with the oxygen. So 9 marks there. So why do we use carbon for the extraction of both copper and iron? Well, there are lots of advantages. Carbon is easily available and plentiful in the form of coke produced from both coal and oil. Carbon is more reactive than iron and copper. It's higher in the reactivity series, so it can remove the oxygen from the metal oxides. Carbon, as you can see here, is just below aluminium, so it can be used to extract any metal below it from its ore. Anything above requires the use of electricity. Carbon also forms a gaseous oxide, carbon dioxide, which floats off, leaving the iron in a pure state. So that is all you really need to know about ore extraction. So let's make some final notes and then have a go at a few multiple choice questions to check our understanding. And then there's an exam style question to check that we can use that understanding. So good luck, and remember to pause when shown. So how did you get on? So question 1, malachite is the ore for which metal? So malachite is copper ore. What type of reaction is used to extract iron from its ore? So that's a competition reaction between the iron oxide and carbon. Which chemical is found in copper ore? So that's copper carbonate, that green powder. What are the products of iron ore extraction? So iron and carbon dioxide from that competition reaction. Which of these is highest in the reactivity series? Carbon can extract both iron and copper from their oxides, so it's carbon. And how is potassium extracted from its ore? So potassium, if you remember, is above carbon in the reactivity series, so we need to use electricity using electrolysis. So let's mark the exam style question. So as ever, before we tackle the questions, it's a good idea to read and think about the information that we're given. So it says this is a diagram of a blast furnace used to extract iron from its ore using coke. And if you have a look at the diagram, at the top we can see that they're pouring in iron ore, coke and limestone. At the bottom we've got blasts of hot air going in and producing that high temperature of around 1,500 degrees Celsius. The reaction then obviously is going to occur in there. The coke, the carbon, is going to remove the oxygen from the iron. The carbon will form carbon dioxide and float off, leaving pure iron behind. And as it's 1,500 degrees, that iron will be molten and therefore falls to the bottom. So question 1. Gold is much rarer in the Earth's crust than magnesium, yet magnesium metal was discovered very much later by mankind. Explain this fact in terms of the metal's reactivity. Well, gold is very unreactive and it doesn't form compounds, so it's found very easily. It's literally just lying around. Magnesium is very reactive. It forms compounds and so it's difficult to extract. We have to use electricity to get it out, electricity not being discovered till quite recently. So 3 marks I've given there, 1 for explaining about the gold, you can find it, the second for magnesium, you have to extract it, but the 3rd mark is for talking about the reactivity of both, because that's what the question asks you to do. Question 2, what is the main element in coke? So that's carbon. Question 3, write a word equation for the chemical reaction that takes place in the blast furnace. So that's our competition reaction of iron oxide plus carbon goes to, with heat, iron plus carbon dioxide. Question 4, Why do you think the temperature needs to be so high? Well, it needs to be so high so it can melt the iron. Limestone is often added to remove impurities from the iron. Why is it important not to have impurities in the iron? So although we haven't talked about this, that's exactly what they do. They put limestone in, which removes impurities. If you have impurities mixed in with the iron, then the iron's going to be brittle, and therefore we won't be able to use it to make bridges, etc. So a total of 10 marks for that question. Well done, and I hope you're happy with ore extraction. Remember, you can always go through this video again or come back to it later to revise. So thanks for learning, take care, and I'll see you again soon.